In example 3, they're asking us to find the standard form of the equation of the circle that satisfies the given conditions. So part A tells me that the center is at the origin. That would be 0, 0. Goes on to tell me that it contains the point -2, 3. So I like to get a handle on what they're telling me, just to help me figure out what's going on. So there's the center, and it goes through the point -2, 3. So that means the circle's doing this kind of thing to it. Well, that right there is our radius then, right? Because it's a collection of all points that's in at that distance away. So the radius is going to be the distance from -2, 3 to 0, 0. So it's the distance. Well, but that's our distance formula from the last section. So the distance is equal to, if you remember right, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So I'm going to have -2 minus 0 quantity squared plus 3 minus 0 quantity squared. Let's clean that up really quick. That would be a -2 squared and a 3 squared. So -2 squared is 4, 3 squared is 9. I'm going to end up with the square root of 13. Kind of a bizarre number, but there it is. Well, that's all I need, because in order to write the equation of the circle, we need the center, which they gave me, and a radius, which we just found. So our equation of a circle then is going to be x minus 0 quantity squared plus y minus 0 quantity squared is equal to the square root of 13 squared. This is just x squared. This is y squared is equal to 13. And there it is in standard form. You don't need to go any further than that. That's in fact all you can do. So, well, that was pretty straightforward. I liked that one as an example. Our next example, part B on that problem. So part B says, this time the center is at the point 2, 3, and it is tangent to the x-axis. So this does not mean a trig kind of tangent. This is tangent, it comes in and touches in just a single spot kind of tangent. So to get a handle again, 1, 2, 1, 2, 3. Here at 2, 3. Tangent to the x-axis means the circle is going to come in and it's going to touch the x-axis in just a single spot. In other words, it's not going to come through and do this. It's not going to rise above it at all. It's just going to touch it in a single spot. And the single spot it's going to touch it is straight down from where it's at. So that's my radius. So I don't even need to use the distance formula this time. I can just count this. We're up 3 units from that axis. So our radius is 3. So the picture was worth 1,000 words. It gives me all the information I need. Now we can come and write our equation. So we have x minus 2 for the x coordinate of the center plus y minus 3 for the y coordinate of the center is equal to the radius squared. The left side is fine. You do not need to FOIL those out or anything because we want the standard form. 3 squared is 9. There it is. There's the equation of the circle that has a center at 2, 3 and is tangent to the x-axis. You could go the long way and recognize that this is the point 2, 0. Find the distance between these two just to get that same 3 out of it. So, okay, one more example, a little more complicated before we get the applications of circles. This is 3 part C. This time, we know that the center is at the point -1, 3, and it's tangent to the line y equal to. Tangent to the line y equal to 2. Well, again, to get a handle on it, we're going to graph what's going on. -1, +3. And it's tangent to the line y equal to 2. Well, y equal to 2 is a horizontal line. So here's the line y equal to 2. And it's tangent to it. So again, it's going to come in and only touch it in that one spot. So the circle's doing this kind of thing. So that little distance right there is our radius. Well, if we're up at 3 on the y-axis and this is at 2, then that radius is 1. So this comes out to be x plus 1 quantity squared, that was minus the -1, plus y minus 3 quantity squared is equal to 1 squared, just to make sure you're squaring things. We'll write it one more time. X plus 1 quantity squared plus y minus 3 quantity squared is equal to 1. Okay, so there are three different examples of writing the equation of a circle. And notice that in each one of those, I chose to draw a picture to help me understand what the information given was.